Okay, so in this tutorial, I'm going to be showing you how to run a t-test statistical analysis using Google Sheets as opposed to using Excel. Google Sheets is a little bit different from Excel, but it does have lots of similarities. It's not as good of a program, in my opinion. However, with its limitations, it's at least something that's accessible by all students and can easily be shared via your Google Drive. So, first of all, let me talk to you a little bit about what a t-test is. A t-test is a statistical analysis that tries to determine if your experimental group and your control group are different enough to be significant. If I was to toss a coin 10 times, I might get 6 heads and 4 tails. Is that significant? Does that mean that my penny is weird? Is something fishy going on here? You and I would probably say no. We would say no because we know that sometimes random chance is going to cause unexpected variations in data. The thing is how do I know? How do I know if this and this are just due to random chance? Or is the difference between the two groups significant enough? And that's what a t-test does. If you look over at these three pictures pretty much illustrate t-testing. So a t-test, first of all, determines the average of the data, and then it plots all of your data points, and it groups them to see how close to the average that they are. That determines how wide the curve is. And then the t-test does that for both sets of data, and it plots them on the same graph, and it says, okay, well, how close are these two curves to each other? Now, in this case, it says there's medium variability, which means you can tell there's two separate groups. They're not very close to each other, and there's not a lot of overlap, but there is overlap. And I would say probably that in this set of data that we would say that they're too close to each other to accept. In this set of data, there is a lot of overlap. These two curves almost look just like each other. In this case, we say there's too much variability. There's too much random chance going on here. There's not enough of an indicator that the two curves are separate enough or different enough that the differences aren't just due to random chance. So in that case, our hypothesis would not be supported. In this case, you can see that there are two very, very distinct peaks. And these two very distinct peaks show me that these two groups are very different. If my experimental group is very different from my control group, then I can say, I think there's a statistically significant difference here. And so my hypothesis was supported. The experimental variable did have a different outcome than the control. And that's all we're trying to determine. Now, I'm not going to make you do all of this stuff, but I'm going to teach you how to get the computer to do all of this for you. The first thing that I'm going to help you do is teach the computer how to calculate an average for you. So the first thing that we're going to calculate is an average, and you can just type that in. I want my average to go here and here. When you're telling the computer to do an equation or do some math for you, always start off with equals. That says, hey, I want you to do something for me. So you're going to hit the equals button and then put on your caps lock and write in average. Okay? Now it should put in a parenthesis for you, and that says it's waiting for the data that you want it to average. In this case, that's the data that I would like to average. I'll close it with the parentheses, and I'll hit enter, and it averaged it for me, just like that. Now I'm going to do this set of data. Equal button, average, highlight the data, close the parentheses, hit enter. I've got my two averages. Now, if I look at these averages, I might say, wow, those are pretty different. I wonder what's going to happen here, okay? Well, we don't know if our differences are like this, or like this. Notice these guys all have the same difference in their averages. So what type of conditions are we really looking at here? Well, that's when we run our t-test. The t-test is just as easy to run. I'm going to write equals to let it know I want it to do some math for me. Write in t-test. Okay. Now, it's going to want four different things. The first thing that it wants is it wants the first set of data. Notice I am not including my average. The second thing that it wants, so I'm going to hit a comma. The second thing that it wants is my second set of data. Hit a comma. And then it wants to know if the data is expected to go in one direction or if it's expected to possibly go in both directions. If the Daphnia are exposed to a decrease in pH, then their heartbeat will change. I didn't say my heartbeat will increase. I didn't say my heartbeat will decrease. It just said that it's going to change. Since it could either increase or decrease, I'm going to say it could go in two directions. The last thing that it wants to ask me is a little bit more complicated. The last piece of information wants to know if this is a type 1, 2, or 3 t-test. I don't expect you to memorize this. I'm going to tell you that we're doing a type 2 t-test. The type 2 t-test is a t-test when you've got the same number of measurements for each of your groups, but the two groups are not connected. What the heck does that mean? If I took the same Daphnia and I measured it at a pH and then I changed the pH and measured its heart rate, that would mean that these two groups are connected together. That would be a type 1 t-test. But since I just randomly took 5 Daphnia from this group and 5 Daphnia from this group, then that means that the two groups are not the same Daphnia, so they are not connected, but I have the same numbers. Let's say that 2 of my Daphnia died in this one, and I only had 3 values for this one and 5 values for that one. That would be a type 3 t-test. But we have the same number of values, but they are not connected. It's a type 2 t-test. This is set of data 1, set of data 2. It can go in either direction, and it's a type 2 t-test. So I'm going to close my parentheses. I've got everything included, and I'm going to hit enter. Excellent. So I got this value. But what does that value mean? This value is a probability value. It's also called a p-value. And pretty much anything less than 5% chance that the difference between my groups is just due to random chance is acceptable. Well, what does that mean? So if my value was 0.05 and I turn that into a percent, that would be 5%. What that tells me is I'm 5% unsure, but I'm 95% certain that my data is significant. Okay? So for this set of data, this is way less than 5% uncertainty, which means that I am really, really certain. Okay? That's very cool. So I'm going to say the t-test value was less than 0.05. So the difference in the experimental group was statistically significant. The hypothesis was supported. And sorry, I can type, I promise, null was rejected. There you go. Let me move this off to the side. Or maybe not. It's just refusing. That's why I don't like Google Sheets. Okay, so this is a different set of data, and we might get a different outcome. So I'm going to do the same thing with this data that I did up here. So I'm going to calculate the average first. I'm going to go over here. I'm going to hit the equals button to tell Sheets that I want to do some math. I'm going to type in what it is I want to do. I want to get the average. I'm going to highlight the data that I want to get the average for and hit enter. In this one, I'm going to do the same thing. Equals button and average. Highlight the data and hit enter. So it averaged it for me. Awesome. That's great. So now I'm going to have it run the t-test for me. So I'm going to hit the equals button. Okay. I'm going to write t-test. Okay. And this is my first set of data, not including the average, comma. Second set of data, not including the average, comma. Then, if you remember, we don't know what direction. We just know we expected a change in primary productivity. So I'm going to call it a type 2. I don't know which direction it's going to go. And then these weren't the same plant put in different conditions. These were different plants put in different conditions. So that's a type 2 t-test. I'm going to hit enter, and it gives me this value. Holy heck! This value is not less than 0.05. This is significantly larger than 0.05. So if I was to turn this into a percentage, that would say there's a 48% chance, almost a 50% chance, that the difference in my data is just due to random chance, that it is not significant. This value would look a lot like this. There's a lot of overlap there, okay? Which means that these two groups are not statistically significantly different. So I would say that the t-test value was greater than 0.05. So the difference in the experimental group was not statistically significant. The hypothesis was not supported, and the null hypothesis was accepted. So if you remember, a null hypothesis says that the difference between our experimental group and our control group is not significant. And so we have to say, you're right. Null hypothesis, you were right. It was not significant. So we accept the null hypothesis. Not accepted. It should be accepted. Okay. All right. So I hope this explains to you how to run a t-test in Google Sheets, what a t-test means, and how you would analyze the t-test. If you are having any questions, please come and see me and I'll help you out. Have a great day. Thanks.